This is the pre-calculus PERA review for the semester 1 final, and I'm going to call this part 2, and this is going to be the next 10 questions on the review packet. Problem number 11 says a box contains pennies, dimes, and nickels. The total values of the coins is $6. There are 50 pennies. How many dimes are in the box? So I call this just X, Y, and Z just for the sake of argument. I know that 0.01x plus 0.10y plus 0.05z is going to equal $6 because each penny is worth 1 cent, each dime is 10 cents, each nickel is 5 cents. The thing is, they told me there are 50 pennies. So if I know how many pennies there are, and I want to find out how many dimes there are, alright, x equals 50, and I just realized there's a missing piece of information, which is, we're going to say that there are 120 pennies, dimes, and nickels. That's important because I know that the number of pennies plus the number of dimes plus the number of nickels is going to be 120. Well, the nice thing is I know how many pennies there are. What that means is that I'm going to plug this into each of these equations, and I'm going to have a system that only has 2 variables. Remember, if I have a system in 3 variables, I can only solve it if I get it down to 2 variables. So for the first equation, if I know I have 50 pennies, that's 50 cents. So I know 50 cents plus 0.10y plus 0.05z is equal to $6. So my equation is 0.10y plus 0.05z is equal to $5.50. For the second equation, x plus y plus z is equal to 120, 50 pennies, so if I plug in 50 here, means that my second equation is going to be y plus z is equal to 70. And then I'm going to solve that system of equations, and you can just use a matrix, or you can solve it using elimination or substitution. If you use a matrix, it's a 2 by 3 matrix, where you're going to put in 0.10, 0.05, 550 in row 1, and 170 into row 2. It's a 2 by 3 matrix. You go to second, x negative 1, and then you go over to edit, and I always put my new matrix in matrix A. Make sure you change your calculator to say 2 by 3 by hitting 2 enter, 3 enter, particularly if it's already in a different set of dimensions. Every time you type in a number, make sure to hit enter when you're done. Otherwise, it won't lock the number in. Once you're done putting in all your numbers into the matrix, you quit. Sorry, I'm going to go up, that's second mode. And then you go back into matrix again, but this time you arrow 1 to the right to calc, and you find option B, RREF. And once you call that up on the home screen, you have to go into matrix one last time, and you stay with your cursor on names, and then you just hit enter twice. And then the last column of the solution matrix is your solution. Now remember, the 2 variables we were solving for are y and z, which means that the first number is y and the second number is z. Remember that this was our dimes and this was our nickels. And the question asked us to find out how many dimes there were. There must be 40 dimes. Problem number 12, it says Kitchen Corner produces refrigerators, dishwashers, and stoves at 3 different factories. The table gives the number of each product produced at each factory per day. So they make 8 refrigerators at factory A, 10 at factory B, 14 at factory C. Kitchen Corner receives an order of 110 refrigerators, 150 dishwashers, and 114 ovens. Which shouldn't be ovens. I guess it should be stoves, shouldn't it? bestows. Write a system of equations that can be used to fill the number of days each plant should be scheduled to fill this order. Notice the question didn't ask us to solve it. It just said write the system. So we're going to call X the number of days at factory A. We'll call Y the number of days at factory B. Wow, I am having an issue here. Let's get rid of this. That should be an A. And we'll call Z the number of days at factory C. So my first equation is going to be 8x plus 10y plus 14z is equal to 110, because in total we make 110 refrigerators. Our second equation is going to be 16x plus 12y plus 10z, and that's going to equal 150 because we make 150 dishwashers. I suppose I should have written my first equation here to give myself space. So I'm going to move it so I can write the last equation underneath here. The last equation is going to be 10x plus 18y plus 6z is equal to 114. And that would be the system of equations that we could use to find the number of days. Now, if I wanted to find the number of days, it would be a 3x4 matrix, and you can plug it into your graphing calculator to find the solution. But one of the problems on the PERA test is going to give you a problem similar to this and just ask you to identify which multiple choice answer is the system of equations you would use. In number 13, given the following system of equations, evaluate y plus z. So this is a system of equations. We're going to plug into our calculator 1, negative 1, 2, 2, 3, 1, 5, 8, 2, negative 1, negative 2, negative 7, which is a 3x4 matrix. When you get your solution matrix, the last column is going to be in order x, y, and z. So once we find the solution, we're going to add y and z together. The solution matrix I got on my calculator was negative 1, 1, 2 in the last column. So if y is 1 and 2 is z, then y plus z must be 3. Number 14, what matrix would you plug into the calculator to solve this system? Always look out for missing terms. If you have any missing terms in an equation, you're going to put a 0 in its place as a placeholder. Your equations have to be written in x plus y plus z equals constant format. I want you to notice the second equation is missing a z, so there's going to be a 0, z there. So my matrix is going to be 2, 3, negative 1, 1. 1, 2, 0, 3, 1, 3, 1, 4. For problem 15, given the piecewise function, f of x is equal to 5x minus 3 if x is less than 0, and x plus 1 if x is greater than or equal to 0, for what value of x is f of x equal to negative 18? All right, so this is what I'm going to do. Negative 18 is the output. So I'm going to actually set both of these equations equal to negative 18 and solve for x, because I actually don't know which equation can give me that output. So this equation is going to be 5x equal to negative 15, so x is equal to negative 3. And the second equation is going to be x is equal to negative 19. So now the question is, based off these two x values, which equation could you have plugged into? Well, when x is negative 3, you have to plug it into the equation whose domain gives me that restriction. Well, that's the first one, because the first equation is the one where the x values are less than 0. Both of these are less than 0, so I had to use the first equation, which means that for what value of x is the output going to be negative 18? The answer is when x is negative 3, not when x is negative 19, because you can't plug into the second equation, because that one you can only plug into when the x values are greater than or equal to 0. In problem 16, it says, what piecewise function represents the following graph? A piecewise function is just an equation that has a restriction on the domain. So if I pretend for a moment like these are just full lines, we're going to write the equations that go with those two lines. Well, let's start with the horizontal one. That one's easy. That's the equation of y equals negative 1. To figure out the equation of the other line, one of the things you can do is figure out what the slope is. The slope is the rise over run between any 2 points on the line. Well, this one's easy because the rise over run is 1 over 1. So the slope is 1. And the only other thing I need to know is what its y-intercept would be if it were a full line. Its y-intercept would be negative 1. So the second equation must be y equals 1x minus 1. Now, you didn't have to do it that way. The other way you could have done it is you could have taken two ordered pairs, plugged it into the slope formula, found the slope, and then used slope-intercept or point-slope form in order to find the equation of the line. But I think it's much easier if you just interpret it from the actual graph by finding the slope and where the y-intercept would be if you extended the line. All right, so now I'm going to get rid of this, because the way we write this is we write it as f of x equals. Now let's look at the first equation, the one that was y equals 1. I want you to notice that that graph only exists when the x values are less than or equal to negative 3. The reason I picked less than or equal to is because the dot is a closed circle. So we want the inequality symbol that has the line underneath. And since all the values are going to the left, I picked the inequality symbol that goes to the left. Now let's look at the other equation, the one that's 1x minus 1. I want you to notice that it only exists when the x values are greater than 2. I picked greater than because the line is going to the right of that x value. And I used greater than and not greater than equal to because the circle where it started is not filled in. So this would be the piecewise function that represents that graph. Remember, on a multiple choice test, look at the equations and see if they match the lines on the graph provided. All right, we're going to try that one more time. The first thing we're going to do is we're going to write the two equations as if those lines were extended. So let's start with this line here. Notice it has a negative slope, and the slope is negative 1 over 1, because to go from one dot to the next, you go down one to the right one. And the y-intercept is at positive 3, so the equation must be y is equal to negative 1x plus 3. The equation that has the positive slope, this one. The slope, hey, look at that, it's easy, it's 1. And the y-intercept is negative 1, so the equation is y equals 1x minus 1. Okay, but that's not how we write piecewise functions. We really do it like this, so f of x is equal to. Now let's talk about the restrictions. The restriction on the line that has negative slope is when x is greater than or equal to 0. Because I want you to notice that the very first x value is at 0, not the y value, the x value. And it starts with a closed dot, and it goes to the right of that line. I want you to notice the other, that looks terrible, the other line with the positive slope also starts at x is 0. But it's to the left of it. And it has an open circle, so its restriction is when x is less than 0. Number 18. Given the function f of x is equal to x squared minus 5x with a domain of 5, 6, 7. Determine the set that represents the range of g of x if g of x is the inverse of f of x. So here's the trick. This looks really nasty and it's a super simple problem. If this is the domain of f of x, then it's going to be the range or the output of f inverse of x. So they asked me for the range of the inverse. The range of the inverse has to be 5, 6, 7. I'm going to repeat that. The domain of the original function is the range of its inverse. So when they ask me to determine the set that represents the range of g of x, if g of x is the inverse of f of x, then 5, 6, 7, the domain of f of x, must be the range of g of x. Number 19 says, given the function f of x is equal to x plus 2 if x is less than or equal to negative 1, and x squared if x is greater than negative 1, evaluate f of negative 3 plus f of 4. So we have to determine which function this gets plugged into. Since x is negative 3 and that's my input, which function can I plug negative 3 into? Well, it's this one, so I can plug it into the first one. So the first equation, x plus 2, is going to be negative 3 plus 2, which is negative 1. The second function, f of 4, which of those two equations can I plug 4 into? Well, the only one where 4 can be plugged into is the second one, because that's the one where the x values have to be bigger than negative 1. So I'm going to plug it into x squared. So 4 squared is 16, and negative 1 plus 16 is 15. When evaluating these piecewise functions, you have to ask yourself, which function will this domain fall into? That's the equation you'll plug into. Last problem. Given f of x is negative x if x is less than or equal to 0, 9 minus x squared if x is between 0 and 3, and it's x minus 3 if x is greater than 3, what's f of 1? Well, if that's my input, that domain value will only hold true for one of those three equations. Which equation is it? It's this one, because 1 is between 0 and 3, which means I'm going to plug it into 9 minus x squared. So 9 minus 1 squared is 8. And that is all the problems on the PERA, which will be the first 20 questions for the semester 1 final exam.